This is question number 3 from May 21. First part, prove that for all single digit prime numbers p cube plus p is a multiple of 10. So, single digit prime numbers. So, p can be 2, 3, 5, and 7. So, p can take the values 2, 3, 5, 7. These are the single digit prime number. So, prove that p cube plus p is a multiple of 10. Let us find p cube plus p. This is for p is equal to 2. It is 2 power 3 plus 2, 10. It is obviously a multiple of, this is multiple of 10. P equals to 3. P cube plus p is 3 cube plus 3, 30. Again, multiple of p is equals to 5. P cube plus p is equals to 5 cube plus 5 equals to 130. Again, multiple of 10. And p is equals to 7. P cube plus p is equals to 7 cube plus 7 equals to 350. Again, multiple of 10. So the question was, p cube is a multiple of 10. Hence, you can say, hence for all single digit prime numbers, hence for all single digit prime numbers, digit prime numbers, p cube plus p is a multiple of 10. Second part, show using algebra for n belongs to n. N belongs to n. N means natural numbers. Natural numbers means 1, 2, 3, 4, so on. So for all natural numbers, n plus 1 whole cube minus n cube is not multiple of 3. Is not a multiple of 3. So for this, you need to recall the formula. Formula is a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube, or you can apply the binomial theorem. So a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. So using this formula in the first bracket, because we have to show that n plus 1 whole cube is not a multiple of 3. N plus 1 whole cube, n plus 1 whole cube, n plus 1 whole cube minus n cube is not a multiple of 3. So you can open the first bracket, a minus, using the above formula. It is n cube plus 3 into n square into 1, because this is a, this is b. If you refer to this formula, a and b are there. Next is plus 3n into 1 square, and then plus 1 to power 3, which is obviously 1 minus n cube. You can simplify n cube plus 3n square plus 3n plus 1 minus n cube. So this n cube goes with this n cube, and you are left with three terms only, 3n square. See, and keep in mind that n is integer, n is 1, 2, 3, 4 values. So from here you can take 3 common. If you take 3 common, inside the bracket is n square plus n and plus 1. So the question was, show that is not a multiple of 3. This is not a, so we have this, and the alternate expression to this, n plus 1 whole cube minus n cube. So here, as the bracket is multiplied with 3 and n is integer, so this is a multiple of 3. This is a multiple of 3, but 1 is not a multiple of 3. So this is multiple of 3 and this is not a multiple of 3. So overall, so if one is a multiple of 3, the other is not a multiple of 3. So this sum is not a multiple of 3. So this is not, or you can say, this is one more than the multiple of 3, but simply you can say this is not a multiple of 3. This part is multiple of 3. Obviously, this is not a multiple of 3. So we have the sum. If one is multiple of 3 and the other is not a multiple of 3, so this sum is not a multiple of 3. So overall, you can say that this expression is not like n plus 1 whole cube minus n cube is not a multiple of 3, is not a multiple of 3, or is not divisible by 3. So it's not a multiple by 3. Hence, this is not a multiple of 3 for n belongs to the natural number.